Okay, it's time to start figuring out what we're going to do for stroke for this motor. So I got this getting kind of mocked up pretty far now. I think I got the Crocker arms and push rod and cam stuff figured out for now, which is over there. But I need to find out how much stroke I can run with this cylinder length and the piston height where it is with a stock case right now versus raising up real high like that and running a longer stroke. So I can't use my stroker crank here as a mock-up because it won't fit in the case because the flywheels are too big in diameter. So I'm going to have to just measure it and figure out what I need. So basically what we're going to do is we're going to take our measurement stick here and you go from the center of your bearing up to your deck height up there, and we're around 6 1/8 inches it looks like. This is too short. So this is a 6-inch caliper here, which is too short also because that's a 6-inch scale. This is an 8-inch caliper, which is long enough to do what I need to do. So zero that back out. So this has got enough length. That's why I bought it, so I can measure big things like these case slip things. So now we just run this thing out to, I think it's about 6 1/8, so there's 6.3, 6.08 is too far. Oh, that's 6.6, dumbass. 6.090. Okay, and 140 is too much. Okay, 6 1/8, 125, 126 is close enough to 125 for me. So now we go to the center of our case and our deck up here and see if they look the same. They look pretty close, about 6 1/8 inches. Could be 150, could be 100. It's hard to tell. It's close. If I had to guess, I'd say it's a little higher. Now, one way you can tell where you're at on a dimension, you take your tangent line, which is going to be really hard to do with one hand. So if you're pushing right here, you're not centered. If you put pressure on it, it changes around the arc, and when it's straight to what you're measuring, which is my V angle, which is right there, then you know you're dead center on the race. Your center line will be here, and you'll be accurate from here to here. I'm going to need two hands to do that, so I'm going to get rid of this tripod over here and do that. So let's see if we can figure out what we got. And we don't have to have this deck, this cylinder on here either. Push rod cover mock-up still going on over there. Okay, so now I get a clean surface to measure to. I'm going to move up to 150. I think that's about where it's going to be at right now. 150. So we got to line up with the mark right here and come off our tangent line right here. There's our tangent line, and we're still more height yet. I didn't think it was anywhere near that kind of a length. Out there, 6.261, that'd be 6.250. So that's an 1/8 inch more than I thought it was. So 6.250 would be roughly about to here. I sure didn't think the bore was that far down, but 250 would be like that far down. I don't believe that for a second it's that far down. I ain't going for that. That should be true, but I'm not going for it. I think my length is, I need to be straight. Got to be in line with where you're measuring. Whoa. to be on the same plane, which I thought I was. Yeah, we're same plane. The angle's different though. Yeah, the angle's different. Perpendicular is right there. Okay. 6159. So 6150. I can go with 6150. I ain't going with 250. The problem was I wasn't perpendicular on my angle. I was a little bit off. So that means you had to stretch further to get to it. So I eyeballed it more perpendicular. So it's all about having the angles straight when you're doing stuff. It's not the best way to measure, but when it's together, that's what you got to work with. So, okay, if we go with 6150, maybe it's 100, like I said before, I'm not sure. At least we got something to go with. Okay. Next thing I want to figure out is my piston. I know that they use an 8-inch connecting rod, so it's from the center of the crank pin, plus your stroke, plus 8 inches, plus your piston height, and your deck height will give you an overall height of your motor. So, in case you didn't catch all of that, you have a piston. Compression height is the center of the wrist pin, the top of the piston. Not the dome, but the top of the piston. And so you got a dimension right there. So, for now we're going to take some dimensioning. Where's my pin at? We're going to take our case deck height. Got some scratch paper right here. So we got 6.150 case height. Okay. Then we take that's going to be the top of our case to here. Okay, the other dimension we're going to have is we're going to have an 8-inch rod, because that's what our rod is. That's on a different dimension though. And then we've got to have our compression height in here. The rod's going to be the center of the piston down here. We got to add in our height up here. When you're all done, these two dimensions have to match. Okay, so now we take our piston here and go here. Go to the center of the wrist pin. I'm thinking 1.6 is pretty close. I think in the book it was 1625 or some weird number, but yeah, I'm at 15 right there. I'm around 615. Now we know this wrist pin's 1 inch because I measured it before. 9985. Okay, so if you measure from the top of the hole to top of the piston, like that, make sure it's not tapered, okay. Right to the edge, right to there. We got 1092, 1091, we'll call it 90, and you got a 1/2 inch of that. You take 1.09, you got a 1/2 inch, it'll be 0.5, equals 1590 is the compression height. So I was at 625 by eyeballing it. So if you go, oh, gotta re-zero that. Well, we have 590, we came up with 590. 597, 591. Okay, right there theoretically is dead center in the wrist pin hole. So, I don't know, it's close, not sure. Theoretically it's pretty close to 590, 595, right in that area. I like even numbers, 1/600. I'm going to go with 1/600. So you put 1.600 on this side. Now we stick in our stroke we want to run. I like to run 4.625. That's what I like to run. Okay, so if you take your 8 inch, your 1.6, and your 5/8 stroke, you should have your number. Now, the 5/8 stroke, there's going to be half of that for height. because stroke is top and bottom. So you gotta cut that in half. That'd be 2 5/16. So this would be 2.312.5. So now if you take that, and that, add them together, you should have a number down here. We're going to round them a little bit. So we got the 8-inch, that's easy. You got the 1.6, we made that easy. And we're going to make that 310. So that'll be 2.310 equals 11, 9, 10. 11.910. That'd be in inches. So that's the overall height of our piston all the way up. So if you measure it from here all the way up, 11.910. So that'd be almost full size. Well, this only goes to 8 inches, I don't know. Where'd my tape measure run off to? There it is. So we're basically on the 12 inches. Pretty close to it. So if you go to the center of your crank, your piston all the way up, like this, that would be the top of your cylinder. If you got room, that's where the motor would be. Right there, it'd be that tall. And it would drop down 4.5 inches, which would be way the hell down to here, which would be way past the bottom of our skirt. So we need more height. We need a longer connecting rod, it looks like to me. Okay, so that's assuming I did my measurements right. I go back and recheck. It seems a little short, but we'll see. Now we got a 5/8 motor over here. There's a 5/8 motor. So if you take a 5/8 motor, stick it on something and flip it around on, something like a big bore cylinder. Oh, there's a big bore cylinder laying right here. Boom. Take your crank. Doesn't matter which side. Lay it on top of your cylinder. Try to make it flat, hopefully. Well, I want to get with that one. You take your piston and put it on top of your rod, kind of in the center, about like that. See, this is real flimsy mock-up. Now, measure and see if it's 11.9 inches. Should be 11.9 inches if my math is right. And I am not to get 11.9 inches because that's not an 8-inch connecting rod. It's only a 7.7, so we're going to be over about 5/8 of an inch short. So I am getting about center of the crank is about there. About 11 3/8. 5/16, 3/8, right in that area. Piston's kind of wobbling, so I'm not sure. Yeah, call it 11 3/8. So you take 11 3/8, 11.375, and you add in the difference between the connecting rods, which is 600, so like 300, 280 actually. Add in 0.28 equals 1165. Did I do that right? The rod is 440, should be 7440. 8 minus 7.744, yeah, equals 256. Okay, and we add that to, what did we add here? 11 3/8, wasn't it? Yeah, a little bit more than that actually. Yeah, we're definitely 3/8. we're definitely in the 3/8. We'll put 11.4 plus 11.4 equals, so 11,650. So it's supposed to be 11,900. 910. I'm not quite coming up with the same number. So, not sure why I got an error in there, but there's an error in there somewhere. Alright. So about 300,000 different, quarter-inch difference. And only a quarter-inch. What's a quarter-inch between friends, right? So I did something wrong. So what am I doing wrong? These are 7.44. 8 minus 7.44 equals, there's my error. I got 560. Okay, now we add in our 400. 11.375 actually. There's my 1193. Math wrong in my head. Okay, that puts us within 20 thou. So I'll go with that number. We're just kind of eyeballing it. Okay, so 11.9 seems to be about the right number for what we're trying to shoot for, so we're going to go with it. Okay, doesn't hurt to do a hard backup physical check and try to duplicate the numbers you think you get in math. Alright, so there's that. The more rusty cylinders come in handy. Okay, so now we got to come up with the other number. So our deck height, whatever our piston drop is in our cylinder. So here's our cylinder. Turn it off. Here's our piston. Cylinder's over here. Okay, so we know this is a 6.150 is our deck height from here to the center of the crank. Now I got to figure out how more this piston is going to go into the cylinder. So it goes in there about that far. Now the top of the cylinder does not quite go all the way to the top of the register in there. It looks like it's about maybe 100 thou back at least. Feels like it's a good 100 thou. And then this here will actually go in there and bottom out like that far in on the piston. So you've got a couple things you can measure from the piston up to here, subtract the difference in here, and add it all together. That's one way of doing it. Probably the most accurate, or one of the accurate ways. Or you can take your scale, and you look inside the hole, and you put this down there as far as you can think you need to go to get it to line up. And you measure the difference. Well, this scale's too short, so it ain't going to work. Now we're going to take our caliper and measure with our caliper. So at the back of the caliper, we got this measuring stick on here. So I'm going to run that thing way on down in there. I'm going to pull it back to whatever I think the cylinder is. If I had to guess, I'm somewhere about that high. About 830. So if we go 8.4 inches, what the hell? My dimension's a little off because my zero's off. What the hell happened there? I had this set for something else. Always make sure your tools are zero before you do your measurements. You don't get goofy numbers like that one was. Okay, we're going to do this again. So we go all the way down until I think it's about flush. See, I'm looking down a tube trying to see the end of a cylinder, so it's hard to tell where you're at. Okay, so I'm going to go 6.157, so 6.5 inches. Ah, poke myself. Now I'm going to go back and check it again and see if I think I get the same dimension twice in a row. Something about there again. 6.529, this is about 15 thou more. So it's around 6.5 inches it looks like. Try it again. Now none of these dimensions are in any kind of a book, so I can't look them up. What did I get this time? 6.491. Okay, so we're consistently coming around 6.5 inches of height. Okay, then you got to take off this off of that height, which is how much? Looks like a 1.279. I like to measure my hard scale. Yeah, it's just under 3, so it's close. Measure that again. What? Yeah, 250. What happened there? One 260. 1278. Keeps growing. There's a fillet in there. That's the problem. 268 again. 278. All right, so we're in that area. We'll go with 275 because I got nothing else to go by. Okay, where's my cheater pen? So down here, put some dimensions there. 1.275. We had 6.5 inches. These are just my note sheet here. Double check everything one more time. 15 times in a row. If you keep getting the same dimension, you might be close. .480. It's definitely that 6.5 area. Okay, and then over here, I'm going to measure this a little differently this time. There's a fillet on the bottom of the cylinder, which makes it hard to read. A fillet is this radius lip right in here. See how the radius in there where the O-ring sits? And I keep hitting inside of that. So I'm going to get on a flat surface here and a flat surface here. If I take the scale, if I go like this, get me a flat surface, and we should measure between flat and flat, I should have an accurate dimension. We were around 275, 280, 290. We're varying a little bit. So it's close to 300, but we're not sure exactly what. So now I do a hard measurement like this. I'm getting 1.280, so I'm going to go with 280. So I had 275, so I'm going to go with 280. That's a pretty hard dimension that time. Repeatable. Okay. So we got 6.5 inch cylinder, 1/250. So if you take these in separate, discount these two from each other. Calculator disappeared. So you take your 650, get a little higher again. So 6.5 minus your 1.280, 1.28. We come up with 5,220. 5.220. Okay, that's our number. Now, if you take the 520, which is this gasket surface here, and you add this number to that number, that's how far the piston can go up into the cylinder before you hit the head or run off the end of the cylinder. So I'm going to take that number, add it together. So I got 5,220, 5.220, and that gives me 11.370. So that's how much clearance we got to hit. And we have 11,910 is what we needed. So there's a mismatch in there of about quite a bit. That's 600, about 580 different. So if you take the 11.9, 11.910, damn it, 910 minus your 11,370. Okay, I'm missing buttons here. 11.91 minus 11.370 equals 540 minus 540. So we're off by a ½ inch.